Today I'd like to welcome Harry Feilen and Jake Fladeland from the University of North Dakota. Now, for those of you that don't know a lot about North Dakota, here are some chilling facts. On average, North Dakota sees over 50 days each year at sub-zero temperatures. In 2022, the coldest day in Bismarck was negative 49, and the coldest day in Bauman was negative 62. Yikes! So I have to ask Harry and Jake, how do you guys stay warm in the wintertime?
You just get used to it. It's a condition, and that negative 49 and negative 62 is actually the ambient air temperature. You take wind chills, and it gets significantly colder than that quickly. And it's just something you get used to. I don't wear any more than a Carhartt jacket usually, but again, I'm not outside mowing the grass. I mean, you're outside long enough to get to your destination and then get back inside. Most of our equipment is a closed cab with heaters. And my forklift does not have a closed cab or a heater, so that is a little bit cold to be outside. But I'll get on the forklift, go outside, unload a pallet out of a semi, and drive it back in just my normal work shirt, because you just get used to it.
Yeah, that's incredible. That is way too cold for me.
16 degrees feels warm today.
Right.
I guess it is all about perspective, isn't it? So Jake, I would love for you to share a little bit more about your background and how you ended up at the University of North Dakota.
So I started working for Patterson Drilling while I was still in high school. The day I turned 18, I could finally go to a drilling rig, and that's all I ever really wanted to do until I got into my mid-20s and seen how clean and just been worked around enough engineers that it seemed like something I wanted to do. So University of North Dakota was the closest to where I was working and closest from North Dakota, so it made sense to come over here. I was part of the first graduating class of petroleum engineers in 2013, and since then I've been out in industry, worked with EOG and did some pipeline work for Hess, and my most recent experience in the field was a drill bit design engineer. And then I've known Harry since our undergraduate days, so he called and said they were building a drilling and completions facility here in Grand Forks, and had to jump all over that and get on board.
Jake, that's a very interesting path to get where you are. I heard you mention clean, so I'm assuming you were sick of being dirty all the time, and now you only get dirty some of the time?
Correct.
And Harry, you have a very unique background. So you started in the military and then went to law enforcement, and then you ended up being the director of the Drilling and Completion Lab at the University of North Dakota. How has your unique background allowed you to really help lead the research projects there at the University of North Dakota?
Well, I think my time in the Marine Corps and working in law enforcement helped me deal with conflict resolution, helped me deal with managing teams and how to spearhead projects to a point of completion. So when I came to UND, I came to college late in life. I was 40 when I went to college for the first time ever. I mean, in high school, I couldn't wait to get out and get away from it. And then, like you say, I did my stint in the Marine Corps and then some law enforcement stuff. And then I went back to construction again. And then I decided it was time to go to college for the first time ever at age 40. So immediately when I got into college, I got hired by chemical engineering as a student employee, fabricating graduate students' projects and helping them weld and get their projects put together and assemble their projects and make them functional. And then it's just been a graduation since then. And 2 days ago, I was appointed the director of operations for the College of Engineering and Mines. So now I'm taking over the operations for the entire division of engineering.
Harry, congratulations on that new promotion. I really love that. First of all, not many people go to college for the first time when they're 40. That is an amazing story in and of itself that you should really never stop learning. If I remember correctly from our last conversation, you didn't just stop with one degree, but you've really been a continual student there while you're at North Dakota, correct?
I'm working on finishing my fourth degree now. I've got a business management degree. I have my undergrad is mechanical engineering, my master's is in mechanical engineering, and my doctorate, which I've been working on for way too long now, is in energy engineering.
Man, I love that. What an awesome and inspiring story. I hope that any of our viewers who see this story are inspired, because this is not the typical path, but you show all of us that you should really never stop learning. Tell us a little bit about the University of North Dakota's Drilling and Completion Labs, or DRCOLA. What do you guys do? How did it start? And what are your capabilities?
Well, some of the people who might be tuned into this might be familiar with a company called Terratex Industries. Terratex Industries started the drill and completions lab in like 1972. What they wanted to do was to test drill bits for actual oil and gas exploration. And they developed this, they put this whole device together, and it's the only rig that I'm aware of that tests at real world conditions. So we have the capabilities of applying a confining pressure and overburden stress pressure. We can get our flows of our mud, and we do use actual industry mud, and we get those up to the prescribed points, and then we can start our drilling regime. We drill any type of rock that the customer would want or that the customer might expect to see in their formations. And we drill about 5 feet deep at a time. So the drilling doesn't last very long, but we do have everything already set to those conditions so that that drill bit actually functions as if it was downhole in a real oil and gas exploration setup. And during that 5 foot of drilling, we gather a ton of data and give that back to bit developers. We give that back to drill operators. We give that back to the paying customers, and it lets them know where their set points should be when they get to that depth, so that they don't damage the drill bit, they don't stick the drill bit, they actually get through at the fastest rate possible and without destroying things.
That's an interesting history of how the Dracola lab was started. Is your drilling apparatus able to test temperature as well, or mainly pressure and hardness of the rock?
Pressure and hardness of rock. We're looking at doing some increase of the pressure of the sample or the temperature of the sample itself. The problem is we have a pipe that the sample sits down into. It's probably 2 to 3 inches thick, and we have to derate that pressure rating as we go up in temperature. So we haven't looked really hard at it yet because we're still in the assembly phase. We're really close to having it up and running, but when we do get it up, we're going to look at how much heat we can actually add to that sample and not derate our pressure so we become unrealistic. I mean, I can drill into a super hot rock right now in ambient conditions, but as you and I in the geothermal world knows, you're never going to find ambient conditions with super high temperature rock. You must include that pressure. And we've also learned over the years of operating this that pressure is what determines the rock hardness, how fast you can penetrate, what it's going to do to the drill bit. So we've got to find a way to marry all of that together and get a real world setup so that we're giving them viable data back.
Yeah, that makes sense. The potential reduction of cost to test in your lab versus the real world is probably a fraction of the cost of testing it in the real world scenarios, correct?
In real world, you're actually going to damage your well. You're going to either follow the bit and lose it, or break the drill string, or do something that's going to damage a multi-million-dollar well. Whereas here, you're talking couple $100,000, and we can destroy it all, rebuild it, and put it back together again. As far as the bit and the string and the, I mean, we can test to the point of failure here and not have that catastrophic multi-million-dollar loss. Not to mention, if you mess up the well, now you've got different reports you got to file. You've got different methodologies you have to follow to seal that well off. And then you got to move the entire rig and possibly lose the ability to explore that vein that you were going after, whether it be a geothermal vein or a oil vein or a gas vein. You might lose that ability to chase that if you have to move your rig. So it's several $1 million if you mess it up in the real world, as opposed to if you come into the lab and do some outside of the box thinking and testing, it's going to cost you a couple $100,000.
I love that. I think that public-private partnership you offer is a valuable opportunity for private companies such as us to test and research their new technology or methods right alongside you in your lab.
Absolutely. Yep. Yeah, we'll partner with anybody who has a project that we can. I want to add value to the industry, so we can test wherever we want in the core holder and with different drill strings and different muds and different cutting methods and everything. So I want to partner with anybody who wants to explore any of that, even if it's just validation, of some tests that they've already ran. They got a new idea. They want to change their soldering method on their PDC cutters. Okay, fine, change that. We'll come in and test it and make sure that it does what you say it's going to do. Give them that third-party validation of their claim to show that this works.
Yeah, I think that's a very valuable and a great proposition to other companies or institutions you partner with. So question, with all of the government regulations and negative sentiment around traditional oil and gas drilling, where do you guys see the future of drilling and the drilling industry?
Go ahead, Jake.
I see the advancement of coil tubing technology, mostly in our area. That's where I can see the most gain, having a continuous. But in that aspect, a lot of the stuff right now isn't set up for monobore technology, so your wellbore isn't one consistent diameter. You're still going to need different drill bits to taper down, just because of the changes in pressure in your throughout your stratigraphic column. So you'll still require that. But as far as the capabilities with coil tubing, you can do multilateral stuff. A lot of the technology that currently is mainly being utilized offshore. There are some companies in the Williston Basin trying dual and triple laterals. But I think with the advancement of coil tubing technology, that would be the next step, is to where all your laterals, all your production zones will be drilled with coil tubing, and the day of the single lateral well being drilled in the state will soon go to the wayside when they finally can get a good handle on that technology.
Yeah, it does seem like the oil and gas industry takes a lot longer to adopt new technologies, right? And I don't know if that's because it's so expensive to test and make mistakes, but I see what you're saying, Jake, that new advancements in technology can really help us improve the industry.
And I think you have a point there, Andrew. You know, the oil and gas industry takes a while to accept new methodology, because we just talked about it. It's a multi-million-dollar error if it doesn't work. And I'll give you my 2 cents on your question there, you know, talking about the traditional drilling industry and how that's going, especially with everyone trying to get away from their carbon footprint and everything. The clothes that we wear, the things that we buy, the chairs that we sit in, I mean, everything that we use in everyday life uses petroleum products. You know, I think these companies in places like California and Texas now, and, you know, some of these other companies that have had problems in the cold weather, they've had problems with brownouts, they've had problems with supporting their electrical grid. You know, we've had other countries that are coming back to coal and other industries that are for generating electricity. So I get it. I understand it. We're all trying to be responsible, but I think the biggest thing that we should probably be looking at is, how are we utilizing the resources that we have responsibly? You know, buying an electric car does not make you a zero carbon footprint. You know, an electric car, yes, it's a good idea. Yes, it's clean. Yes, you know, we can save some gas and save some of the environment that way. We have to look at those raw materials and how they're being taken, how they're being stripped from the earth. What damages are we doing to the people and the earth and the entirety of the big picture? These people that say, I buy an electric car because I want to save the planet. Well, you're destroying the planet by buying the electric car. The way that they mine these lithium products and, you know, some of these other things over in the Congo and stuff, it's just totally destroying the planet. And people are like, well, I want to go green. You're transferring your carbon footprint to somebody else, not to mention the damage you're doing to the planet to gain those resources. That's my 2 cents. I don't think oil and gas is going anywhere. I think it's just a political coin that gets thrown around, and I think the next political regime that comes in is going to sit back and look at it. And, you know, I don't want to name names on your podcast, but the previous president, we were doing great oil, you know, energy independent. We were doing good oil stuff, and then now in the current regime, the oil companies like it because the price of oil went up. But, you know, it's creating problems at home and problems with everyone's pocketbook. And, you know, we just need to be smart about it and understand, how are we reducing our carbon footprint? We reduce our footprint by getting these resources responsibly.
I think you made some very important points there, Harry. There's a massive misconception about being carbon neutral and reducing the carbon footprint because, to your point, that energy has to come from somewhere. Energy isn't created, nor is it destroyed. It just changes form. When it comes to electric vehicles, there's a massive environmental impact to mine lithium, cobalt, or any of those other precious metals needed for batteries. So you also mentioned the Congo, and I've read reports that aren't really mainstream yet that the working conditions in those cobalt mines are subhuman, and there's a lot of death and dangerous work conditions. Those stories haven't really hit mainstream yet because the labor and environmental issues to make electric vehicles possible is against the positive narrative. But I agree that the oil and gas industry's impact beyond providing us fuel, a part of our everyday life, it will be impossible to eliminate that completely from our lives. So I do see a future where the oil and gas industry really remains important.
I think the United States has done a wonderful job with maintaining our expectations and not polluting the environment and doing responsibly retrieving these resources as responsibly as we can. We identify a problem, we address the problem, we correct the problem, and then now that becomes a new policy. So it's not like you get into some of these third world countries, like you were mentioning, people are dying doing this. They have 255,000 people mining these things in the Congo, and like 46,000 of them are kids under 6 years old. How is that sustainable? So yeah, I agree. I think we need to manage our expectations. And yes, we want Clean Air Acts. We want, things from the EPA to step in. And, Jake can attest to, you can't spill an ounce of oil on a drill rig or you're going to have problems. That's the thing. Like you said, one, it goes against the narrative. And two, people don't realize that this very cell phone that we're talking on, these computer screens that we're talking on, all contain such a heavy amount of rare earth elements that, where are we getting that from? Where's that coming from? We actually have a project at UND that's looking to find resources to get these rare earth elements. So, and we do it responsibly. We can't just go out there and destroy things and tear up, the ecostructures and everything and just start tearing into things. And well, we want that because we're humans and we can do that. Well, yeah, okay, if that's what you want to do, but it's not responsible.
I agree. It's not really as simple as others make it seem, and I appreciate your perspective. Does the University of North Dakota have any experience with drilling for geothermal energy or specifically drilling through hard rock to reach super hot rock?
We do have a couple people in our college. That's the wonderful thing about being in a university. I have chemical engineers, I have mechanical engineers, I have civil engineers, I have geologists and geological engineering people. So when it comes to, do we have experience? I have an entire division of people that may have touched it in a different place or different time. Will Gosnell right now is in our geological engineering department, and he's done some geothermal work. He's looked into it. He's worked with a couple companies who are doing some geothermal drilling. And has UND done any drilling, especially with Dracola? No. Are we looking at it? Are we looking to expand our capabilities into that? Yes.
And I think drilling is drilling. And Jake, one question for you, having worked with drill bit engineering in the past, the challenge of hitting super hot rock at 400 degrees Celsius, people have theorized that if you can drill 5 to 6 miles anywhere on the earth, you can hit that 400 degree temperature. But when you drill that deep, you have massive pressure and extremely hard rock. From your perspective as a drilling expert, how does the industry overcome that to be able to drill through such hard rock with that much heat and pressure?
Well, there's a lot of different ways to look at it. First, you're going to be looking at what your environmental constraints are. Are you able to use what kind of drilling fluids are you allowed to use? Definitely, that's your first consideration. Next, when you're looking at temperatures like that, you first got to look at the process of building your bits. A lot of the PDC technology right now, you struggle even with the temperatures you need to hit to braze your cutters in. You can degrade the diamond table of the PDC cutter at the same time. This is just in the assembly. And when your drill temperatures reach that supercritical point, it becomes even more valuable to be able to cool your bit. Currently, oil-based drilling muds are the best method to cool something like that, just because the lubricative properties and the heat disbursement. But you get into environmental constraints where you're doing air drilling or foam, you lose that ability to cool your bit and also protect your wellbore and maintain hydrostatic equilibrium. So it's kind of a multifaceted question, but you need to first answer the question of your regulatory environmental constraints and then approach it from there. But yeah, there's always going to be certain points, especially temperature-wise, when you get into that, you can completely damage a bit. We call it DBR, damage beyond repair. You're definitely testing that supercritical line that I'm not familiar with. I haven't gotten to the point where we've ever had to worry about severe thermal damage to a drill bit. But when you're talking those depths and those temperatures, you get even closer to that, where drill bit cooling and your drilling fluid that you use becomes your main consideration.
I agree with that. I think what's interesting is that the oil and gas industry has had over 100 years to develop such technology, but they haven't needed to. The cost to drill for oil was too attractive, and because the oil and gas industry is slow to adapt new technology, so we're seeing non-traditional tech companies now that are racing to find new ways to drill and reach these temperatures to potentially change the playing field of energy production. But I think it's clear that without government support, whether that's through grants or subsidies or access, it'll be difficult to accelerate those technologies. But what challenges do you guys think the geothermal drilling may have in comparison to drilling for traditional oil and gas drilling?
Well, and I think you made a point already that, you know, an oil and gas company is there to make money. They know the depths they got to go to. They've done this 1,000 times. We're not teaching them anything new. They're setting records every day. So now you're going to switch gears and have them go into a geothermal setting, and they're going deeper than they normally do. They're dealing with more hotter rock than they normally do. I mean, the purpose behind geothermal is to inject water or some medium down hole, have it absorb that extreme heat, and then come back up hole and transfer that to an electrical, whether it's a turbine or however you want to make that into an electrical situation. So I think the biggest challenge is allowing, like you said, you know, government involvement where we can get these independent contractors who don't necessarily have their daily job as drilling for oil and gas to step in and say, hey, I got this idea. We can try this. We can try that. But again, we need a test facility like the Dracola test facility or something where we can actually try it, because to get to that depth and then have your idea fail is going to be a multi-million-dollar venture, even if you're not drilling for oil and gas. I mean, just to get to that depth in the beginning is not cheap. And then to test out the new technology at that depth is going to be even more expensive should it fail.
Well, I think the University of North Dakota and specifically the Dracola lab is well positioned to assist companies really test new drill bits or methods, because you've built a lab, a team with expertise, and really are able to help people test. And we'll keep you guys in mind as we get closer to testing our new drill bit and technology. I've had a lot of fun with you guys today and appreciate your time and honesty. And Harry, your inspiring story is wonderful to share with others. Stay warm, and I hope we'll be in touch soon.
Okay. Thank you, Andrew. Nice talking with you.